We'll move forward to the next speaker, Professor Dr. Sameh K. Abd-Elmabod from the National Research Center, NRC of Egypt. He's in the Department of Soil and Water Use with expertise in GIS, soil science, climate change, water resources, remote sensing, ecological assessment, agriculture management, spatial analysis and modeling for the analysis of global change. Very good academic credentials, and the topic of presentation is past and future impact of urbanization on land surface temperature in Greater Cairo over a 45-year period. The floor is yours.
Thank you very much, sir. First, I would like to thank His Excellency Professor Adel El-Beltagy for the invitation, and a very big pleasure to give a talk in the session that directed by Professor Lal. So, first, we studied the status of urbanization in the whole Nile Delta, and Greater Cairo is included over there. So, in the left side, we can see the land use, land cover of Egypt. We are living on only 5% of the total area of Egypt, 100 kilometers square. In the right side, we can see the location of the Nile Delta and its 13 governorates. Sorry. And we studied the biophysical line. In the left side, the sub-figure A presents the elevation in Nile Delta, where the elevation ranged between 7 meter below sea level, and it can go for 700 meter above sea level in immediate surrounding areas. In sub-figure B, we can see the dominated soil types, where the dominated soil order is anti-soil and aridi soil, and the dominant subgroup soil is vertic refluent that occupied around 29%. Sub-figure C represents the irrigation and drainage canal, and D the land use, land covers of the Nile Delta. In the right hand, we can see the over time, 4 datas, the changes in normalized vegetation index. So we can see the agricultural land have lower NDVI value in October because the farmers are preparing the land for cultivation or sowing. That's why the NDVI value is low. And when the winter crops are fully grown, so we can see in February increased the normalized vegetation index values. With the same trend that's happened also in summer crops. For the climate in the study area, we can see below the 15 millimeter in the past 5 years. This is the mean precipitation for Cairo Meteorological Station. However, the precipitation can reach to 160 millimeter in Alexandria, but this is extremely arid, not sufficient to cultivate any crop. So we take in account the amount of water that enter from the river Nile, and we can see another figure where the yellow areas have been disappeared. The yellow area represent the aridity. So when the evapotranspiration more the amount of water, it appears this area. So the top figure represent the water amount that receive any governorates in the Nile Delta, and also the amount of water that distributed by the different type of crop season, where the Kahleya more water receive and summer crops more water receive too. So we studied the land use, land cover in the Nile Delta using imaging processing and remote sensing technique. So what we found that the urban area have increased from 450 kilometers square to 2,650. That means we lost around 5 million feet done of the fertile soil. 5 million feet done. Half million feet done. Half million feet done of fertile soil. On the other side, we see also how much is the expansion of new agricultural land in the immediate surrounding area. So we can see that the agricultural land have increased over the 45 years by 8,000 kilometers square. That means 1.9 million feet done. And the more time of reclamation land was between 1984 to 1992. Then the rate of reclamation land is slowed. And here we can see images that shows the different land covers that we can see in the Nile Delta, informal urbanization, the most fertile soil, reclamation of new cultivated lands, planned urbanization, and aquatic vegetation close to the North Lakes. So in the other figures, we can see that the total population of Egypt was 36 million in 1972 and increased to 100 million. So even, however, the agricultural land, it was 25,000 and increased to 37,000 kilometers square. So that's why the agriculture area per capita have been decreased. Even we reclaimed 1.9 million feet done because the increasement of new cultivation land not meet the huge increasement of population. Also, we studied the impact of this urbanization on soil carbon. So here we can see the map of soil carbon for the whole Nile Delta. We can see how much the old land, it's very rich in the soil carbon content compared with the new cultivated land. So we lost from 25,000 megagram, now we lost due to urbanization 141,000 of carbon stock. So urbanization and the climate change, the majority of scientists that working in the climate and the earth science, the opinion about the global warming, they said it's largely caused by human. But few of them said human have no impact on climate change. So let's go with the majority, but even not the majority not always right. Here we can see urban heat island. What does it mean, urban heat island? Heat islands represent that we have an area that have temperature, more temperature rather than surrounding area. So that's mean heat island. If this area have temperature less than the surrounding area, it can called cooling island. So the cooling island it's a water bodies and green space. And here we can see how the air surface temperature and the land surface temperature in the downtown is high compared with rural and the sub-rural areas. So we did papers that already accepted. So we see the land cover, how it changes the land cover in Greater Cairo, and how is this, it changes in land cover by reducing cold islands and increasing heat islands can affect the land surface temperature. So here we can see the agricultural land in the Greater Cairo dropped by 150, while the urban area have been increased by 170 kilometers square. So here we can see the ground photo for the major land cover. The techniques is based on using satellite images with 30-meter resolution different satellite images, and also we measure different indices: vegetation index, water index, building index, and the land surface temperature interval. Here we can see that the land surface, we studied the land surface temperature over the summer months from May to August, and over 45 years. We can see how in the land surface temperature in 86 had the lower land surface temperature compared with 2017, and is a predicted year in 2030. This figure, so okay, we said, okay, let us know exactly how much is the area of each land surface temperature. So we calculate how much area occupied each land surface temperature to see exactly how will be the changes. So here in this figure, we can see that there is a steadily increasing in land surface temperature, where is the mean value going toward this higher land surface temperature values. And this is totally agree with the work that presented by Peter Gillick, that said in the new climate, sorry, the figures not appear, in the new climate there will be more extreme drought. So that's, we can see month of May, it's extreme change, extreme shifting towards a higher land surface temperature compared to the other months. Even the other months also have a higher shift. Then, okay, we said, let's see the different land cover, land use that we have. We did small plots, around 330 small plots, and to represent the different land cover, land use that we have. So we have totally water, agriculture, totally agriculture, agriculture associated with urban, urban associated with agriculture, and totally urban. So we can see here the red line represents the mean land surface temperature, while the water bodies has the lowest land surface temperature value compared with urban. And
Please try to conclude in 2 minutes.
okay,
Thank you.
thank you. And here we can see a fine contour map. So we choose six plots distributed in the Greater Cairo, and even the plot A, there is no changes in land cover, but there is increase in temperature as a result of changes in the surrounding areas. So in the other figures, we can see in the figure C and D how is the urban area is increasing and how it can affect increase itself in temperature and affect in the surrounding area. In the other figures, we can see the different months in each plot, how is the increase in land surface temperature over the time. We studied the hot plot. We studied the ring road, the western side of the ring road, and we see how it changes in land cover. So the agriculture and land was 72 in 86, and now the urban area is 72. So that's lead to high. So in establishing routes on agricultural land accelerates the urbanization process, and this acceleration in urbanization process lead to increase the land surface temperature from 31 to 37. We are speaking about 6 degrees, and it's predicted to reach to 38.9. We did the same in the buffering zone around the River Nile, but there is no changes, big changes in land cover, but there is still a change in land surface temperature, were increased by around 4 degrees. This may increase the evapotranspiration. The sub-figure A represents the changes in the mean temperature over the summer months. So we can see how we are speaking about 5 degrees. The other figure that when we reach to critical temperature threshold, the crop will be reduction, and then when I think now we are going to the limiting threshold, when we will have a failure crop. So then we studied, we just masked the agriculture area in 2017 to see how it affect on agriculture area. It was 30 degree and now it's 35. So around 5 degrees increase and it's predicted to reach to 36. Then we see the urban area. We only masked the urban area. So the urban area has a mean temperature was 33 and now it's 38. That means it affects the thermal comfort and the energy will be need more energy. So here we see the transect.
Just a second, Doctor.
Okay.
Professor Lal, I discovered that we had the written program say that this session ends on the 17th, which we still have until 5 o'clock if needed. We can make a panel form or whatever, but I just have seen a written program that your session, this session ends up on the 17th.
So each speaker can have 30 minutes? Is that what you're saying?
Yes, yeah.
Okay. My
And we
apologies.
can go back to Dr. Dwevi after that if he has further comments. Thank you, Professor Lal. I'm
So
sorry.
we'll make
Bye.
it 30 minutes rather than 15 minutes.
So
Thank you, Father.
so I have time? Okay. Perfect. Perfect.
Yes,
okay.
you have another 10 minutes.
Thank you very much. Okay, we did a transect, and this transect is land service transect. And this transect is, the length is 2 kilometer and 100. So this transect is divided to sub-transect. So we have a value each 30 meter. This is the resolution of the satellite image to see the impact of water bodies and green space, park, and the golf and agricultural area in reducing land surface temperature. So the red line represents the land surface temperature, the blue line represents the water index, the green line represents the vegetation index values, and the gray line represents the urban index. So when we have the first one is the River Nile, transect passed from the River Nile, so we can see how the land surface temperature is dropped. And here this is the rule of water bodies, how the changes in land surface temperature, and this is the impact of green spaces in reducing land surface temperature. So regarding to the mitigation of land surface temperature, so the atmospheric factors like wind, cloud, precipitation, air pollution, and the fog, it will affect it will indicate us how to mitigate the urban heat island effect. For example, depending on the population in a city, Palo Alto, that have 33,000 inhabitants, the threshold for really mitigating the urban heat island is ranged between 3 to 5. On the other hand, in London, where the population is 8,500,000, the threshold of wind is 12 meter per second. So here is the mitigation strategy, as Professor Osama and Professor Abu Al-Hadid presented, the rule of rooftop vegetation in reducing the urban heat island effect phenomena. Also should be an air corridor, green spaces, water spaces, and we can use energy efficiency. This also strategies to reduce the urban heat island impact. And regarding to the infrastructure, we should use a material that have high albedo. The other image represent the different albedo values for the different material. So these strategies help us to reduce energy consumed and lower carbon dioxide emissions, lower nitrate oxide emissions, and lower ozone. So the conclusion is urban heat island, it may lead to climate change. increase the evapotranspiration, and lead to changing land use, land cover. We know all we know is that the meteorological station is limited in covering a concerned area, but with using remote sensing, high accuracy data, it's a very benefit. So our result helps the plan, the decision maker, to know the cool benefits that come from the cultivated land around the city and the role of water bodies and the green space in reducing the land surface temperature that can reach to 6 degrees. Urban sprawl should go to the desert, and there is a big challenge to Egypt to cultivate new cultivation land, especially under extremely arid conditions. And as Professor El-Beltagy said, we are going to acute water poverty is less than 500 cubic meter per year per capita. So this study that we did, it can be useful for any other country that have the same condition. Thank you very much for your attention.
Thank you, Professor El-Beltagy. That was an excellent, very comprehensive, very detailed observations on impact of urbanization. And sorry that we had to interrupt you. You had more time than I initially thought, but you made some excellent points, and I took note. Maybe there are some questions. We will also go back to Professor Duari for his extra time in case he needs it. I was very impressed that you indicated population in 1972 was 36 million, then present 100 million. As a result, very rapid urbanization, where the carbon stock decreased from 250,000 megagram to 141,000 megagram. And per capita agricultural land area decreased. The temperature due to urbanization increased from 31 to 37 degrees Celsius. Very remarkable. Therefore, I think it brings back to the question, the need for protecting prime agricultural land against encroachment by urbanization.
As you said, sir, the soil have a right to be protected.
Have a right to
Yeah.
protect. Yes. Thank you. Any comment, question from the audience? Any questions?
The audience, عشان ما فيش قهوة ولا شاي ولا غدا، ما فيش أسئلة كمان. اتفضلي. أنا دي ميكروفون. اتفضل.
Thank you so much for your presentation. The question is, can we connect this work with wheat productivity, or we can say strategical crops in Egypt, especially in Delta region, to compare the land surface temperature raising and with production of our strategical crop like wheat and so on. So what do you think of connecting previous work like historical data from temperature and connecting is with predicting the impact of the rising temperature as the impact of climate change on our wheat production, and how mitigate this? Thank you.
That's a very good question. That there is a recent publication paper in Global Change Biology. It's a very good journal. That mentioned that the increasing of land surface temperature and the changing and the urbanization and the emission of warm gases can lead to decrease the wheat yield in Egypt to 50%. 50% of reduction due to the changes of land cover land use. Yeah.
Thank you. Yes, there is another question from Professor Mahmoud Ayad-Duari. You are muted.
Thank you very much. I have a comment, since we are talking about the problem of water resources in Jordan, and just it was mentioned about the population, the increase of population in Egypt. Jordan also, we have suffered in the past years from dramatic increase in the population, And this was due to the influx of refugees, first from Iraq and then from Syria, and before that, from Kuwait, the Palestinians. So we have increased, which puts a lot of pressure on the water resources in Jordan. I mean, we were suffering before,
Exactly.
and when we have this influx of people, that is our water resources have been affected. In addition, some of the refugees.
Your microphone, Professor Doueri, I think we need the voice much more clear if you can increase the volume. Thank you.
Now, what about now?
Yes, good.
Okay, I may repeat maybe, that, the increase in the population of Jordan has been tremendous because of the refugees problems. We have refugees from Syria, more than 1.3 million. We have refugees before that from Iraq, and before that even we have more refugees from the Palestinian refugees or the refugees who were in Kuwait. They came to Jordan. So this has really put a lot of pressure on the capacity of Jordan in the different aspects, especially in the water aspect. So this is really, we are suffering from the poor water capacity, and this has really put a lot of stress on our water resources at that time. In addition, some of the refugee camps were settled on the top of some of the aquifers of water in Jordan, and this really created another problem. So this is really, I think, should be taken in consideration, that when we write or say something that this is about the water resources, how we can help Jordan into this aspect.
Professor Abd-Elmabod, do you have any?
Yes, totally agree. When we have more population, more stress on natural resources that we will have. So that's totally agree. Yeah.
Well, I want to thank you again, Professor Al-Mabod. We do want to go back to Professor Doueri, but let's first thank you for excellent presentation.
Thank you very
I
much.
think very top quality work that
Thank you.
I had not seen monitoring urbanization impact on
Dr.
soil and
Sameh.
climate. So going back to Professor Doueri, we did not have to